Welcome to Vidyakshetra YouTube channel. Electricity powers everything from a small LED bulb to giant machines in industries. But what really happens inside those wires? Three fundamental quantities, voltage, current, and resistance, form the backbone of every electrical circuit. Let's break down each one and see how they work together. Electric current is the flow of electric charges, specifically electrons, through a conductor like a wire. Its symbol is I, and the unit of measurement is the ampere, often shortened to A. Current is measured using an ammeter, a device specifically designed for this purpose. The formula for current is I equals Q divided by T, where Q represents charge in coulombs and T is time in seconds. When you switch on a fan, electrons start moving through the copper wire, and that's the electric current powering the fan. Think of electric current as water flowing through a pipe. The more water flowing per second, the greater the current. Voltage is the force or pressure that pushes electric charges to move through a circuit. It's the push that causes charges to move in a wire, with its symbol being V. The unit for voltage is the volt, also denoted by V, and it's measured using a voltmeter. The formula for voltage is V equals W divided by Q, where W is the work done in joules and Q is the charge in coulombs. A 9V battery pushes charges with a pressure of 9 volts, allowing a small LED to glow by providing enough push for electrons. In our water analogy, voltage is like water pressure. More pressure leads to a faster flow of water, resulting in higher current. Resistance is the opposition offered by a material to the flow of electric current. Its symbol is R, and the unit of measurement is the ohm, represented by the Greek letter omega. Resistance is measured using an ohm. The formula for resistance is R equals V divided by I. A bulb's filament resists the current, converting electrical energy into light and heat, which is what makes it glow. In our water model, resistance is like the size of the pipe. A narrow pipe offers more resistance, leading to less water flow. Ohm's law states that the current through a conductor is directly proportional to the voltage and inversely proportional to the resistance, assuming temperature remains constant. The fundamental formula for Ohm's law is V equals I multiplied by R. This means if voltage increases, current increases. Conversely, if resistance increases, current decreases. For example, with a 9V battery and a 3 ohm resistor, the current, I, would be 9 divided by 3, which equals 3 amperes. In a light bulb, electrical energy is converted into light and heat due to the resistance of its filament. A fan converts electrical energy into motion through the current flowing through its coils. A phone charger safely converts 230 volts AC to 5 volts DC, controlling the voltage for your device. The key idea is that all devices depend on how voltage, current, and resistance interact. To recap, voltage is the push, current is the flow, and resistance is the opposition. And remember Ohm's law, V equals I multiplied by R. Every time you turn on a switch, these three invisible heroes, voltage, current, and resistance, come together to make electricity work for you. Don't forget to like, share, and subscribe to Vidyakshetra for more educational content.